Hello friends, this is Kik, and in today's episode, you're in for a treat. We have a unique rocket engine the size of a fingernail that runs on water, iPhone 15's that seem vulnerable to subpar USB-C chargers, a new robo-dog that runs without using motors, and Agility Robotics that's launched a humanoid robot factory, seemingly outpacing Tesla. We also spotlight an extreme unicycle that races up to 68 mph, and Rocket Lab's unfortunate mishap during the satellite delivery of Acadia into orbit. All this and much more coming right up. Let's dive in. We'll kick off today's episode with scientists from Imperial College London who've developed an incredibly tiny rocket engine, the IceCube thruster, based on iridium-catalyzed electrolysis. It's so small that its manufacturing employs methods used in semiconductor chip production. The engine is tailored for compact satellites, known as CubeSats. Given that up to 90% of space launches cater to deploying CubeSats weighing up to 10 kg onto near-Earth orbits, with many being no larger than a standard smartphone, crafting suitably sized components becomes quite a challenge. Among these challenges is creating rocket engines that adhere to the physical constraints of these satellites. In this case, the engines must not only be small, but also extremely simple, non-vacuum, low power, and devoid of toxic materials. The entire length of the IceCube thruster, funded by the European Space Agency, is roughly 2 centimeters. With its combustion chamber and nozzle being merely 1 millimeters, it requires just 20 Ws of electrical current to operate. During tests, the engine generated a thrust of 1.25 millinewtons at a specific impulse of 185 seconds consistently. For perspective, this is 500 million times less than the thrust of engines used in space shuttles. Yet the novelty of this micro-engine isn't in its thrust strength, but in its fuel source. Plain water. It's as non-explosive and non-flammable as you can get. Electrolysis takes place with the electric current, splitting the water into hydrogen and oxygen, which are then channeled into the combustion chamber to ignite, generating thrust for satellite maneuvering. The use of water is not only environmentally friendly, but also reduces the overall mass of the apparatus since it eliminates the need for complex storage and delivery systems. But we'll circle back to space later. For now, let's see what's happening right here on Earth. Jessa Jones, owner of the American Service Center iPad Rehab, has sounded an alarm regarding a critical detail of using the iPhone 15. It turns out that these new models are susceptible to low-quality or counterfeit chargers and USB-C cables. Jones explained that such chargers wouldn't protect the iPhone from a voltage surge as they lack Apple-certified technologies. According to her, the official Apple Lightning cable is equipped with 2 chips, one to authenticate the accessory and another that acts as a fuse. In the event of a voltage spike, only the charger would break, leaving the phone intact. Jones also advised users of non-genuine iPhone USB-C chargers to avoid plugging into hotel outlets, airplane seat ports, car consoles, and the like. If a voltage surge occurs, recovering a damaged iPhone 15 would become impossible. Well, since we started on the topic of Cupertino's blunders, let's continue. In the first days of accepting orders for Apple's latest generation smartphones, it became clear that the wait times for the flagship iPhone 15 Pro Max model extended until mid-November. However, experts explain that this delay is not only due to high demand, but also technological challenges in producing the periscope-type camera module, which debuted in this generation of devices. Renowned analyst Ming-Chi Kuo stated in his blog that the compact camera module with 4 prisms, supplied exclusively by LG, was the culprit behind the iPhone 15 Pro Max shorter gear. To ensure an adequate yield rating for this component, Apple urgently ramped up the technical specifications for the lens system provided by Largan. This adjustment aimed to reduce defects during camera module assembly. Delivery wait times for the iPhone 15 Pro Max currently average between 5 to 6 weeks, marking the longest waiting period among all iPhone models released in the past 7 years. Meanwhile, Agility Robotics is launching its first facility dedicated to the mass production of a humanoid robot lineup named Digit. The new factory, dubbed RoboFab, aims to assemble up to 10,000 units annually and will employ 500 people. Funded by DCVC and Playground Global, Agility Robotics has outpaced potential competitors, including Tesla with their Optimus initiative, by finalizing the design of serial humanoid robot prototypes and opening a factory for their mass production. Digit's humanoid design allows them to lift, move, and sort loads maneuver while maintaining balance, and operate in environments where steps or other structures might limit other robotic solutions. The robots are powered by rechargeable lithium-ion batteries. The only thing missing in Digit is a 5-fingered hand. Instead, the robot's hands resemble a claw or mitten. Human-like hands are intricate, the developers say, hinting that such a manipulator might be introduced later on. The company plans to use these robots for transporting materials and parts within their own factory. Privileged partners of Agility will be among the first to receive the robots next year. In the the near future, the company intends to sell the Digit robots rather than leasing or renting them out. Speaking of robots, a Canadian student roboticist has constructed an experimental robot that continues to move on a treadmill even when its motors are switched off. A counterweight is all it needs. The young man drew inspiration from the kinesiological characteristics of animals. The resulting bilaterally symmetrical robot is fitted with metal rods serving as bones, 3D printed polymer pulleys for joints, and thin steel cables to simulate tendons. Just like a real dog, each of its 4 legs possesses 3 joints, mechanically coordinated with the others. During the initial test of Michael's machine, a surprise awaited. Once the robot's drives were activated, it continued to move autonomously without the support of the motors, with the treadmill's operation being the sole component needed to sustain movement. Specifically, it reaches speeds of up to 6 km/h on the treadmill. Nonetheless, the bot isn't a perpetual motion machine and still employs its motors for movements like jumping and stepping over obstacles. Let's move on. A significant event has taken place in the world of electric vehicles. The company in motion has introduced its new unicycle named Adventure. The foundation for this remarkable mode of transportation is an electric motor with a nominal power of 4,000 W and a peak power of up to 9,000 W. These specifications allow the unicycle to accelerate to an astonishing 110 km/h. But that's not all. The new model can climb inclined surfaces at an angle of 50 degrees, making it ideal for mountain rides. Moreover, the unicycle is equipped with an innovative suspension with variable rigidity, ensuring comfort and safety during jumps and other extreme maneuvers. The lighting system adapts to each rider, and the quick-release battery can be replaced in just a few minutes. The battery also supports fast charging, restoring 80% of its charge in just 1 hour. Thus, the new unicycle from InMotion is not just a mode of transport, but a real breakthrough in the world of electric mobility. It offers both high speed and maneuverability, as well as safety, thanks to well-thought-out technological solutions. Did you know that in the early stages of Tesla's business development, the Japanese corporation Toyota was a shareholder of the company and assisted with the design of the electric vehicle powertrain? But now, it's time for the world's largest car manufacturer to learn from Elon Musk's company about advanced body part production technologies. Toyota also plans to cast under pressure just like Tesla. In traditional methods, large assembly units in a car body structure are made from stamped fragments which are welded or glued together and also fixed with threaded connections. By forming a monolithic base fragment of the body using pressure casting in a single pass, the manufacturer eliminates numerous intermediate operations, each requiring its own technological equipment and time. The precision of the monolithic part's geometric parameters increases, the risk of defects in production is reduced, and the vehicle body manufacturing process is significantly accelerated. Specifically, the prototype casting equipment using a powerful press that Toyota showed to journalists produced the rear part of the body base in 3 minutes, compared to several hours. Given the enthusiasm with which both Tesla and Toyota are moving towards the adoption of such technologies, the question of their application is no longer up for debate. While Tesla has a limited range of models that are seldom updated and produced in vast quantities, there's no contesting the appropriateness of producing monolithic body parts using this method. Toyota also produces cars in huge numbers, being the world's largest car manufacturer, but it has a much wider range of models. Preparing casting equipment for each model is an expensive venture. And as promised, more on space. The aerospace company Rocket Lab conducted a launch of the Electron carrier rocket with the Acadia radar satellite from Capella Space. However, a few minutes after launch, the flight of the carrier was terminated due to an anomaly in the second stage engine. The satellite was lost. Telemetry data, which the company broadcasted during the live stream, indicate that the velocity of the Electron rocket's second stage began to decrease shortly after its sole Rutherford engine should have started. This suggests that the flight might have been terminated due to an anomaly in the second stage engine, such as an ignition failure or premature shutdown. Rocket Lab did not announce the exact cause of the failure, promising to provide more information as it becomes available. The current Rocket Lab mission was named We Will Never Desert You and intended to place the Earth remote sensing satellite Acadia into orbit. It was equipped with technology to create high-quality images of our planet's surface. It was supposed to reach its calculated orbit about an hour after launch, but due to the rocket engine's malfunction, the device was lost. For Rocket Lab, today's launch was the 9th this year and the 41st overall. The unsuccessful launch ended a streak of 19 successful launches in a row. The company's last rocket failure occurred in May 2021.